In this course, we're going to cover how to deploy web applications to Amazon ECS, which is their Elastic Container Service. So Amazon ECS is a way to run containers on AWS. It requires that your application be containerized, essentially using Docker, and it's basically a way to manage container orchestration to help you deploy and scale your application. So in this course, we're going to go over how to deploy a traditional web application using ECS to allow us to scale and orchestrate those containers without having to manage that process ourselves. So to start with, I will cover why you might want to use ECS as a deployment mechanism. So the most basic way to deploy a web application is traditional single server. You provision your server with the runtime and dependencies you need. So that might be PHP, Go, Node, whatever it is, and then you just upload your code somehow. And then as your traffic grows, you just upgrade your server. So you get a bigger and bigger server, and that'll actually get you pretty far. Like, biggest server on AWS is ridiculously huge, and almost no one is going to exceed that single server capacity. So that's a pretty traditional, easy way to deploy your code. There's a few obvious downsides to this. So if your traffic or your load on your server is pretty constant throughout the day, then this approach is perfectly fine, right? You have a lot of traffic, you upgrade your web server. But if your traffic is very sporadic, maybe you have a lot of traffic at certain peak times and then not much traffic at other times, you're essentially always paying for a server provision to your peak load. It also has the problem that there's no redundancy. If your web server goes down, you are basically offline. So one way to solve the redundancy issue is with a load balancer. So you can basically put a load balancer in front of your web servers, which the client will send requests to the load balancer, and the load balancer will determine which server to forward that request on, and then wait for the response and return it back to the client. So you can run a load balancer with HA proxy or something similar to that yourself. Otherwise, the cloud providers offer fully managed load balancers, and this solves for the redundancy issue. If one web server goes down, the load balancer stops routing traffic to it, and then your other backup web server or web servers can handle that traffic. And this also gives you the ability to scale. You might just add more and more web servers as your traffic increases. The obvious downside to this, again, is there's no elasticity. If your load on your servers varies throughout the day or the year, you're basically always provisioning this fleet of web servers, and your load balancer is just routing traffic between them. So you solve redundancy in the sense that if one goes down or two goes down, you still have reserve capacity, but you're still essentially paying for all these web servers all the time. So the next thing you can kind of do in your architecture is add elasticity to it, which essentially you basically set up autoscaling. So this is something that's pretty common with AWS, for example. So you would have a load balancer, you would have an autoscaling group monitor the health of your web servers. So they would basically monitor the CPU or the memory usage or the latency or any combination of various metrics on the web server. And as your web servers start to get overwhelmed, it'll spin up a new server for you and tell the load balancer that there's been a new server added to the cluster, and the load balancer will start routing traffic to it. So you see in this top example, when there's not much traffic, we just have a single web server behind the load balancer. And then as we get more load or more traffic, we start spinning up a new web server. And then as traffic decreases, we can basically scale down and turn off web servers that aren't necessary, which saves us cost because we basically pay per hour based on the size of this web server. So this is basically what we're aiming for when we use ECS, is to get this balance of elasticity. So we only want to pay for what we need and have the redundancy and the load balancer there routing traffic between the web servers. So the reason we would use ECS for this is because it allows us to orchestrate containers. So you can imagine trying to use this architecture without a containerized application. It would be very tricky. So when your auto-scaling group recognizes that you need a new server, you would need to spin up a new, for example, EC2 instance. You would need to provision that with the correct runtime. So you'd need to install Node or PHP or whatever runtime you're using. You would need to install any dependencies. You would then need to pull your code down and then let the load balancer know that it's safe to start routing traffic to that server. So if you're using containerized applications, all you need to do is just grab a container that's ready to go, drop it on an EC2 instance that is set up or configured for running Docker containers, and you're good to go straight away. So it's a much, much faster process to spin up new servers, which is where ECS fits in really, really nicely.